I'm Ryan, and today we'll be looking at a simple lab experiment involving buoyant force and weight under fluid statics. But first, we need to understand what is fluid statics. Fluid statics is a branch of fluid mechanics that studies fluid at rest. In other words, it involves fluid under stable equilibrium condition, which does not involve any motion properties such as shear stresses and change in momentum in fluid. Now, under fluid statics, common phenomena include buoyancy and flotation. As objects are immersed in fluid, their weight acts downwards. An upthrust will be produced to counterbalance this weight, and this upthrust is known as buoyant force or buoyancy, or by definition, the net effect of the pressure forces on the immersed body's surface. When the buoyant force is less than the object's weight, the object will sink, or otherwise known as negative buoyancy. But when the buoyant force is more than the object weight instead, it will lift the object up and make it float, or also known as flotation or positive buoyancy. Now when the buoyant force is equal to the object's weight, the object will stay in neutral position, which is neutral buoyancy. Now, to verify this relationship between buoyant force and weight is where this experiment comes in. And the methodology is relatively simple. For this experiment, you just need water, an egg, a volume measuring tool, and a weight scale. First, fill up the volume measuring tool with a certain volume of water. Then, get the egg and measure its mass. And finally, put the egg into the water and measure the increase in water volume or water displaced. Alright, now that all the procedures are done, let's see what data we obtain. So for the egg density and water density, I obtained their values online, which is 1031 kilograms per meter cube and 998 kilograms per meter cube respectively. G is the gravitational acceleration with the values of 9.81 meters per second squared. Mass of the egg is 62 grams or 0.062 kilograms, while the volume of water displaced or increased in this case is 75 millimeters or 0.000075 cubic meter as measured earlier. With these data in hand, we can now calculate the buoyant force and the weight. But before that, we require the volume of the egg as well, which we can get by dividing the mass of the egg by the density of the egg. This gives us 0.000060136 meter cubed. Now we can calculate the weight of the egg, which we do by multiplying the egg density with G and volume of the egg. From that, we obtain the value 0.6082 Newton as the weight of the egg. For the buoyant force, is actually equal to the weight of water displaced, which holds the formula of density of water times G times volume of water displaced. This gives us a buoyant force of 0.7343 Newton. Now, remember the definitions of buoyancy introduced earlier? Well, that came from Archimedes' principle, also known as the physical law of buoyancy. It basically states that a body submerged in fluid at rest is acted upon by a buoyant force which is equal to the weight of fluid displaced. But wait, from our calculation earlier, if the buoyant force is larger than the weight of the egg, shouldn't the egg float due to positive buoyancy, you may say? Instead, from our observation earlier, the egg actually sank when placed into the water. Well, here's the trick. Our calculations earlier only considered the content of the egg. But in reality, an egg might not just be composed of fully egg white and egg yolk. In fact, there's actually air inside the egg, which contributes to some weight as well, hence why the egg sank instead of floating. And since the egg sank, it is safe to assume that the weight of the air inside the egg is at least 0.1261 Newton. All in all, the relationship between buoyant force and weight is verified, and the objective is achieved with the application of Archimedes' principle. Even so, the experiment still has a lot of room for improvement, and the result will definitely improve with the use of professional lab apparatus. With that, thank you.